So database design is a huge topic in your syllabus, huge topic. It will take about at least 3-4 days to do this. Uh, and you get both second paper and first paper question on database design. Right. So far we have discussed how to understand and model data related requirements, entities, relationships, attributes, and some concepts like composite attribute, uh, multi-valued attribute, derived attribute, identifier, then one-to-one, one-to-many, many-to-many relationships, unary relationship, binary relationship, ternary relationships. Okay. And also we discuss weak entity, strong entity. Okay. Uh, Associative entities, so many. Now, once you understand the requirements, data related requirements, our next task is design in the database. Right? So, easier part is done, that is understand the requirement. But as engineers, IT professionals, so our main task is design the solution because we want to develop software. So almost every software has a database component because we want to save data, update data, later retrieve data. So therefore, behind almost every information system, there's a database. So how to design that database that fulfill the requirements or the data requirements? That is what we are going to look at. It's a serious stuff. Designing the database is a very important part of designing your software. Okay, information system. So when we design, there are a few things in our mind. Right? We want to reduce the duplication of data. So we want to keep one data in one place as much as possible. So that is called reduce the redundancy. And we want to enforce data integrity. Integrity means our data must be interrelated. Rather than data is something like islands, not connected. So ideally your data must be interconnected. Okay? That is super important. And other than that, we need to think about the performance, security, and some other aspect of data management as well. Right? So that is what we want to do. So database designing is two-step process. Remember, we have already done analysis and model the requirements. Now we are into the designing. So it's a two-step process. Two-step process. These two steps are called logical design, physical design. Right? Logical design and physical design. So what is logical design? What is physical design? So logical design is the initial design. Or sometimes we call it conceptual design, but we don't use the word conceptual because conceptual modeling is used for analysis. So therefore we prefer to use the word logical design. So logical design means still we have not committed to the specific technology. So there are different database management systems like Oracle, MySQL, right? Microsoft SQL or MS SQL. So then there are some other database technologies like NoSQL, like MongoDB. There are object-oriented database management systems. So logical design means we have not selected the exact DBMS, but we have decided which approach we are going to use. So that means there are different types of databases, types. Like most widely used these days is relational. We discussed that. Okay. Relational, object oriented, NoSQL database. NoSQL is a type of database. Object oriented database is a type of database. Relational is a type of database. So similarly, early days we had network databases, hierarchical databases on anyway, we don't use those anymore. So we do logical designing after deciding which approach we are going to use. Relational or object oriented or NoSQL or anything else. We have decided that, but we haven't decided exactly what is our DBMS. That means we know we have decided which approach we use, but not exactly which DBMS. Is it clear? Okay. So, so therefore, when we do logical design, it is not very close to the technology or reality because still we haven't decided the DBMS. Okay. But we have committed to the approach. So therefore, we have a guideline now. From this point onwards, when we say logical design, we almost all the time refer to relational databases. Logical design for relational DBMSs. Or little bit of object oriented also, but majority relational with little bit of object oriented support, right? Because we are not going to discuss about NoSQL or nothing. It's relational and bit of object oriented support. So later when we go for physical design, we will decide, okay, whether we go for MySQL, Oracle, Microsoft SQL, and so on. In your syllabus, we don't care much about the physical design because then you need to learn about these different technologies, right? So we are more interested in logical design. Logical design, assuming that our database management system is a relational database management system. Okay. If you don't understand if anything that I talk about, I mention, just then and there raise your questions. Okay. Right. So physical design is now you have decided, okay, we'll use MySQL. No, we are going to use Oracle. No, our database management system is MySQL, MS SQL. That is now we are into the physical design. So here physical doesn't mean something tangible. Remember, in general, physical means what? You can touch. You can touch like a vehicle, machinery, food items. Those are physical, right? So we call physical touch. When you handshake, there's a physical touch. Whereas conceptual means it's concept. But here physical doesn't mean you can touch because anyway, software databases are not something you can touch, right? So therefore, first of all, you need to understand this. So what do we mean by physical here? What do we mean by physical here? It is not, it doesn't mean that you can touch something. Is anyone doing physics in your A level as a subject? Anyone here? No one? So what is the meaning of subject physics? Physics. So because we have similar meaning. Physics means physics doesn't mean always physical things, tangible things. For example, in physics subject, student learn about light. Light is not something you can touch. Heat. Heat is not something you can touch. Force is not something you can touch. Pressure is not something you can touch, but you can, that is a reality. So physical means reality. In reality, there's something called heat, there's something called light, something called force, something called. So likewise, physical design means we are more closer to the reality. So the reality is ultimately you use MySQL, you use Microsoft SQL, you use Oracle, and so on. That is why we use the word physical design. And it has nothing to do with something you can touch, tangible. So logical means still we have not committed to the reality of the DBMS, rather we are only committed to the type of DBMS. So in our case, it is relational. Okay. Right. So from this point onwards, we will concentrate on logical design. Logical design. And again, logical design under relational databases. That means from this point onwards, our assumption is we are going to develop our system or design our system database so that later we can use one of the relational DBMS. Later we can decide which one is it, Oracle or MySQL or Microsoft SQL. That is where we do the physical design. Okay. But now we have decided, okay, we are going to go for relational databases. So then logical design for relational databases because your syllabus is for relational databases. Right. So the terminology, the words we use in logical designing is pretty much similar to the words we used in conceptual designing. That is analysis. Now we are into the design. But some words are different. 90% we use the same words, but some words we introduce new things. For example, rather than entity, that is the word we use in analysis. Now we call it relation or table. But relationship is still called relationship. Attribute, either we call it attribute or we call it field. Then there are some new concepts like records, right? Null value, primary key, and all concepts like degree of a relation, cardinality is still there. Some new words for all concepts, and sometimes the all concepts we use the old word. Sometimes there are new concepts like null value, right? So you must know what you are doing. Are you talking about analysis modeling or design modeling? So in logical designing for relational databases, the relation is something similar to entity, but we look at it in a design point of view now. Okay. So in analysis, entity is a concept, payment, customer. In designing, table or relation is set of records or set of tuples. Set of tuples. Set of records. Tuple is another word for record. For example, one nimal@gmail.com. Say mail. Two nimali@gmail.com. F. So these are different tuples. So now collection of a tuple is called relation or table. It's a concept. It's a logic. And there's connection between relation and entity because most of the time your entity become a relation or table. There's a one-to-one mapping, but not always. Sometimes, for most of the time, an entity is mapped to a relation or table. Okay, but not all the time. So this is how you look at a relation. Relation is a concept, set of records, set of student records. You call it student table or student relation. Set of customer records or customer tuples. So that create customer table or customer relation. So every table has set of records. Another name for record is tuple. And your set of records or your table has field names. That means every record is a collection of field values. So these fields are mostly your attributes. So most of the time, if there's attribute, then there's a field. But sometimes some attributes are not fields. For example, derived attributes are not fields. For example, age is an attribute, but not a field here. And if you had a composite attribute, it will be multiple fields here. So that is what designing is all about, understanding this mapping. So therefore, what is mean by table or relation? It's a set of related records or tuples. Often, an entity is mapped to a relation or table, but there are some other possibilities as well. Right. So we'll build some more terminology. Some of these terms we have already used in analysis. Most of these terms are not new to you, but maybe one or two terms are new to you. So remember our table or relation is set of attribute records or tuples. Each record is set of fields. Now what is mean by attribute domain of a field? Attribute domain of field is possible number of or possible valid values for given attribute. If it is gender, possible values are male, female. That's it, nothing else. Say if it is, say account type, maybe savings account, current account. If it is district, maybe one of the 24 district in Sri Lanka. But there are some attributes or fields, there are unlimited possibilities. Like a price can be anything, salary can be anything, or it can be within a particular range. Someone's name can be almost anything, right? Attribute of a domain can be very restrictive or very open, or sometimes there are range of values. Then the cardinality of a domain. So cardinality of the domain is number of possible values for that attribute. For example, gender, number of possible values are two, male and female. Cardinality of the domain for gender is two. If it is day of the week, only Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday are allowed. So that means cardinality of the domain is 7. If it is a month, cardinality of the domain is 12. So these are just terminology, okay, words. Next one is degree of a relation or table. So degree of a relation is number of fields or attributes in that relation. For this table, the degree of the table or the relation is 4. So these are just some definitions, okay? Some of these are not very important. Some of these are very important, okay? Because we build a common terminology. I'm doing this part very do this part faster because these are very straightforward, right? Even you can read the note and understand. Fine. So then the cardinality of a relation. Remember we discussed about cardinality of a relationship, one to one, one to many, many to many. We'll get back to that. But this is cardinality of a relation. Cardinality of a relation or table is number of records. Degree of a relation is number of fields. Cardinality of a relation is number of records. It depends, right? When you insert a record, cardinality increase. When you delete a record, cardinality decrease. When you update a record, the cardinality remain the same. If there are 40 students in a class, then the student table will have 40 records. Cardinality is 40. These are not rocket science, right? You can easily understand. Right. Next concept is order of records. Right. Order means in which order your records exist. Say name, date of birth, salary. Say first one is Nimal, second one is Amal, third one is Kamal. Now this is the order of the records. Most of the time this order is the order of record insertion. But maybe you sort it according to the salary and so on. You sort it according to the department number. So by default, we don't care about the order, especially when we give results. But if you are interested in the order of the records in SQL, later on you will learn there's something called order by a particular field. Otherwise, it will be pretty much a random order. Or we don't care about the order. Okay. So that means in general, at logical level, unless you are interested, we don't care about the order of the records. So after first record, there can be fifth record, 81st record. But if you use order by, definitely we can order it, sort it. So remember, we are just building some words, terms. So another concept is null value. If you don't provide a value for a particular field or set of fields, so in database terminology, in database designing, we say that that field has null value. So null doesn't mean that we store a string called null. No, we don't store something like this word. If you haven't set a value to a field in databases, we call that it has null value or no value. Because this is very important, knowing whether a particular field has value or not for a particular record. We will use this keyword when we do SQL as well. Right. Now we are moving to the primary key. Remember, entity can have attributes. Entity can have attributes. And of course, entity must have identifier so that we can uniquely identify a record. So that concept of identifier is translated to the concept of key in designing. Key. And there are different type of keys, different variation of keys. So our main concept is primary key. Primary key. So every table, every relation must have a primary key. So a lot of students misunderstand the meaning of primary. Right? Lot of students misunderstands because you get sometimes fooled by the word primary school. So their primary means prathamika. But in English, primary has two meanings. So one is yes, like primary school. The second meaning is primary means main, main. So therefore here primary key means the main key, major key. Okay. So then we have something called candidate keys, primary key versus alternate keys, concept called super key. Then there are two categories of primary keys called simple primary key versus surrogated primary key. So you need to understand this because in designing, we use these concepts. So let's start with key or candidate key. So the word itself says, right? Candidate key. So candidate key means, so candidate keys are key or keys which are possible candidate for primary key. Okay. For example, say we have a student table now or entity, or now we call it relation. So it has different attributes, right? Student ID, maybe student number, registration number, contact number, email address, and so on. Now you need to select one or more fields, either one field or collection of fields as your primary key. So in order to select the primary key, you need to find the candidate key. Candidates are possible, apekshakya. For example, if it is student table, possibly you have student ID. So student ID is definitely a candidate key. Maybe you have the NIC number, possible key, candidate key. But definitely the date of birth is not a candidate key because it is not going to be unique most of the time. Gender is not going to be a candidate key. Salary is not going to be a candidate. So candidate means possible, possible. So how do you double check whether a particular field is a candidate key? Super easy. Just check whether using that field or set of fields, can you uniquely identify a record? NIC, yes. Student number, yes. But definitely, say student has many phone numbers. So therefore, phone number is not a candidate key. Student name is not a candidate key because there can be different students with same name. Right? It must be unique and it must be minimal. So it must not have additional fields which are not necessary for it to become the primary key. You call it minimality, minimum. It must uniquely identify a record, and that combination or the key field must be the minimum. So then it's a candidate key, like employee ID, NIC number, order number, possibilities. So the next one is super key. Now these are very highly closer to each other. So therefore, you can really get confused also. So candidate key is a possible candidate for key. It must uniquely identify a record and it must be minimal. You don't have extra fields like student ID, NIC, payment number, order ID. So then what is super key? Super key means you have a candidate key plus something more. That means super key is not minimal. Super key uniquely identified a record, but it is not the minimal. If it is not the minimal, it is not candidate key, it's a super key. Okay. Say we have student table. So possibly student ID is possible primary key because that is enough, or possible candidate key because it uniquely identify a record and it's sort of minimal. So then someone might say, okay, so then what about student ID plus name together? Then it is not candidate key. It's a super key. Super key means it has a candidate key plus one or more other fields, one or more additional fields. So then it is not a primary key, then it is a super key. Okay. Now you should be able to give me plenty of examples for super keys. So something minimal or candidate key plus something additional. Say account, bank account. Account number is a candidate key. But if you take account number and interest rate or account number and balance, that is now super key. That means you have the primary candidate key plus something else, something additional. So then out of your candidate keys, when you pick a particular key as your primary key or the major key, that of course your decision, but you can be guided by some best practices. So then that selected key is called the primary key. Here primary doesn't mean prathamika. Primary means main key. Say we had two candidate keys, employee ID, NIC number. So if you are a very realistic person, you will most probably select, maybe if it is student ID as the primary key. Maybe you had the NIC number also. Then NIC number is not a primary key, still it's a candidate key. And also, if a particular candidate key is not selected as the primary key, you can call it alternate key. That means it's as good as the other primary key. But unfortunately, we need to select only one. So therefore, that is not selected. So the unselected one or unselected keys are called alternate keys. All alternate keys are candidate keys. All primary keys are candidate keys. So when you pick your primary key, any other candidate key or key combination is a alternate key. Okay. So this is an example. Say this employee table. Say this is a candidate key, employee ID, unique identifier record. This is another candidate key. It looks like this is another candidate key. I don't like to take name, salary, department ID as candidate keys. Now, out of these candidate keys, we have selected the employee ID as the primary key. So therefore, that is the primary key. Then the unselected keys are simply candidate keys. Candidate keys. Then out of candidate keys, the selected one is primary key, unselected ones are alternate keys. And if you look at any key combination where you have the candidate key plus something else, non-candidate key, then it is a super key. Table can have different super keys. Okay. Right. So now we have discussed about what is candidate key, what is super key, what is primary key, and what is alternate key. Okay. Now we are going to look at two type of primary keys. This is categorization. This is not a concept related to primary key. This is categorization of primary key. The primary key can be categorized as, this is first classification, simple primary key versus composite primary key. So simple primary key means one field, single field primary key. Say student number. So just one field is your primary key means. So primary key means that field can be used to uniquely identify a record in that table. Say we can use student ID because every student has unique student ID. So it's a single field. So it's a single field primary key if you have selected student ID. But there can be situations where a single field is not going to uniquely identify a record. So it's not like student ID, order ID, payment ID, product ID. So there can be situations where single field is not going to work. So then you need to combine two or more fields and take it as the primary key. So then we say that we have composite primary key. So it depends, right? When we design, you will find that there are situations you need composite primary key. Simple primary key is not going to work. So in that kind of situation, we will take composite primary key, like student ID and course ID. For example, many-to-many relationship, we introduce a connecting table. Later, we will look at this, okay? So then that connecting table, you need to give a composite primary key. But these tables, you can have simple primary keys, student and course. But here you need a student and course combination as the primary key. So if your primary key consists of multiple fields, more than one field, it's a composite primary key. Right? So if it is not clear, you can ask, right? If it is clear, I don't want to tell it twice. So that is how we do this class in 2 hours, right? 2 hours, 1 week. I can take 3 hours and say, I keep telling the same thing. So remember why I decided to do this class on only 2 hours because when I did my O level, I hate going to schools. I have told this story, right? I hate going to school. Many times I have told my parents, no, I can't go to school because they have so much of time. 7:30, 1:30, 7:30, 1:30, 7:30, 1:30, 7:30, 1:30, 7:30, 1:30. So they have, like the teachers have so much of time. So therefore they keep selling the same thing because they have no other option. And we have no other option but keep listening to the same bullshit. So in this class, we'll talk about the primary key only once. What is primary, what is simple key, what is composite key only once. Because once is enough, right? If you are intelligent person. Right. So this is our second classification. Second classification, we subdivide primary keys as domain key versus surrogated key. Domain type primary key, surrogated primary key. So this is a little bit tricky. Okay. So what is mean by domain primary key? The primary key is called domain. Domain means business area. Right? Domain means business area or field. So if your primary key field has a business meaning, domain meaning, or we use it in our day-to-day businesses, that primary key field, it's a domain primary key. For example, when you refer to your account number, account in your bank, you always refer to the account number, right? You go to the ATM machine and you need to select your account number. That means you must know what is your account number. Right? For example, when you transfer your money for the classes, so I give you the account number, right? So account number something I must remember. If you are doing transfer, you must also remember, keep it a note. That is used in our day-to-day activities. And of course, my account number is the primary key for the account table in the bank. So therefore, account number is a domain primary key because we use it in our day-to-day activities. Day-to-day activities. If you uniquely identify a vehicle by vehicle number like 28 KBT 3489 or something, so we refer to that, right? So we remember vehicles, vehicle registration number. If there's a fine or something, the police people they will write down your vehicle registration number. So that is used by people. So therefore, if you use vehicle number as the primary key of the vehicle table, that is a domain key because we use it in our day-to-day life. Okay. For example, use NIC, National ID card number. If you use NIC to uniquely identify as person, so that is a domain key because we use NIC number. You write it in different places. When you go for exam, sometimes they ask you to write your NIC. So if you use it in day-to-day activities, and if the user is supposed to know the value, it's a domain primary key. Okay. Sometimes we can use a machine generated primary key in the database table. So we call it auto number most of the time. And these numbers, most of the time, we don't show it to the customer, but it is internally we use it as the primary key. And also we use it as a foreign key later on for relationships. But this is internal tasks. Usually we don't, customers or the users are not supposed to know about it. Okay? And they are not supposed to use it in their day-to-day activities. Most of the time they are not aware of that number also. So then you call it surrogated primary key or machine generated primary key, auto number, mostly auto numbers. Maybe you use your NIC number, but internally it is some other student ID that we use, transaction ID we use, which is machine generated sequence like 1, 2, 3, 4, 5. So then it is surrogated key. Okay. So in A-level ICT, most of the time we refer to domain primary keys, not surrogated keys, because it's easier for you to understand, like saying NIC number, bill number. But in reality, in software development, we most of the time we use surrogated primary keys, not the domain primary keys. Domain keys are used as unique keys, but not as primary keys. But for your A level, yes, you can think of most of the time we use keys. Very rarely we use surrogated keys. But just aware, if you have a machine generated number which is sort of a hidden, and we use that as the primary key, while your other fields are just unique keys, so then it's a surrogated primary key. Okay. Those are more often auto numbers. Right. So remember, still we discuss about primary keys and keys. So remember what is primary key now? Primary key is the selected key that we use to uniquely identify a record in that table or relation. So when you decide on your primary key, you need to pick the best one. Out of the candidate keys, you need to pick the best. And remember, your primary key must uniquely identify a record and it must be minimal. If one field is enough, don't add one another field and say this is my composite primary key. Then it is not minimal. Then it's a super key. Right. So what are the features of a good primary key? Obviously, your primary key must uniquely identify a record. Otherwise, it is not going to work at all, right? So obviously, a primary key, good or bad, okay, it is not a primary key unless it uniquely identify a record, like account number, vehicle registration number, bill number. You can't have two bills with same number, right? And it must not change time to time. If it is going to be changed, that is not a good primary key. Or that is not a good choice. You can see that most of the time we select as primary keys, they are not supposed to change, right? For example, your NIC number. So it's your NIC number is not going to be changed. Though it is a domain key, still it's not going to be changed unless there's a big change in the way government handle citizens. For example, when you buy a vehicle, usually that vehicle number is going to be the same. Maybe after 40, 50 years also the same. That is why sometimes we still have street numbers, dash numbers. So good primary key doesn't change the value over the lifetime. Okay. And also you must not rely on the end user to get the primary key value. So that is why surrogated keys are better. For example, say you assume that you are using NIC number as the primary key. If a particular person says, okay, I can't remember my NIC number, now how do you insert that record? How do you insert that record? Because that guy says, I can't remember, or I'm not very sure about my NIC number. Now you are in trouble, right? So that is why surrogated keys are better. Okay? Surrogated keys are better because we generate the unique number for every new record. Still, maybe we may be keeping your NIC number, but not as a primary, as a unique key. But for your A-level ICT exams, most of the time examiners refer to not to surrogated keys, but to domain primary keys like NIC number, bill number, and so on. Okay. Is it clear what are the features of good? Because this is all about designing. So when you know what are the features of a good primary key, you will design your primary key in a best possible manner. Okay. So that ultimately, you will come up with a good design or best design for your database when you know these concepts. Right. Now we are going to look at how to map different types of attributes in when it comes to designing. If you have a derived attribute, this is from analysis and this is your design. So analysis to design. If you have derived attributes, you can simply ignore it. So you can see employee ID is there. Your identifier has become your primary key. Date of birth is there. But we have not added age as a field because age is a derived attribute. So we are not supposed to save age because at any time we can calculate the age with the help of date of birth and the current date. Of course, every computer you can access the current date, system date. So, so therefore, when you design, make sure you skip your derived attributes. Don't include them into your table. Now you gradually learn more and more design concepts. Actually, now we are doing designing. Second design idea. If you want, you can just take it as a rule. Design rule or best practice. Let's call it design idea. Design best practice. If you have a composite field or composite attribute in your table or relation, make sure you have the sub attributes as the fields. You are not going to have a field for the composite attribute, rather you are going to have separate fields. Say there's nothing called address, but you have number, street, and city. Because when you keep number, street, and city separately, you have effectively keep your address. Keep your address. And also ask why. Now, if someone asks why you don't keep date of birth, because we can calculate date of birth from, sorry, why don't you keep age? We can calculate age from date of birth. And of course, if you save age is going to be different every year. Then you need to go and update it also. So similarly, can you tell me why do we keep these sub attributes as fields rather than this big attribute, composite attribute? Anyone? Can anyone give me a simple answer, explanation, reason? Because your task is question. Education is all about question yourself, question your whatever taught to you. So don't accept anything for granted. Always question and ask valid questions, critical questions. Actually, that is part of the education. If you just blindly memorize things, that is not education. Anyone? No one? No one. That is strange. Right. So the reason is why do we keep our records? Because later we want to sometimes retrieve, search, update, delete. So if you keep it as separately, it's very easy. For example, I can clearly find out who are the employees in this, say, Colombo, who are the employees living in Kandy. If you keep, say, number 35, First Street, Dehiwala, so then you need to extract this and find out where is the city, right? So that is unnecessary process, unnecessary fussiness, right? So rather than you extract this and find out where is your street, sometimes some people's addresses are very weird, like they may be living in a uh, apartment. So then first floor, blah blah blah. So then how do you know whether first floor is a street or floor, or where is your separation of street? So therefore, this is always preferred, right? It make our life much simpler. So designing is all about making our life easy, making the data very easy to access, unambiguous. So always go for the sub attributes. Take your sub attributes as fields if it is a composite attribute. So that is the best practice in designing. Right. What happens if you have multi value attribute like contact numbers, say your language skills. So maybe you know English, Tamil, and Sinhala, all three. You have more than one contact numbers. Sometimes you use Mobitel, sometimes you use your dialog number. So that means there's a possibility of multiple values, but it can't be for your date of birth, right? For your salary. So then how do you make it your design? Design means later on your system database. Because then afterwards we convert design into database. So if you have multi-valued attribute, it's ended up as a separate table. In your main table, don't add this as attribute. Maybe employee has employee ID, name, and contact number. Now keep employee ID and name, but don't add contact number here because there's possibility of multiple values. So then you can create a relationship to another table, and that table you have the contact number. Maybe you can have primary key called contact ID or something just like employee ID, and make sure you have foreign key referring to your table. I will explain what is foreign key in 5 minutes. So therefore, now we know that this 435 number is for employee 125 Nimal Silva. And these two numbers, 92 and 35 numbers are for 145 employee, Ravi's numbers. And this number is for Lily. So likewise, we can always relate. So that is called integrity, relatedness. Your data must be related. Your data must not be isolated so that it makes sense. And also you can see that now you can have multiple contact numbers because you can have the same employee number many times for different contact numbers. And employee ID is not your primary key. Primary key you can't duplicate. Your primary key is this. Maybe this is surrogated key, machine generated number 1, 2, 3. Because this is your primary key, you can have the same employee ID more than once. This is one-to-many relationship. And this is called a foreign key. This is your primary key, surrogated primary key. This is your other primary key. And now this multi-valued attribute has ended up as a one-to-many relationship, new table. New table, and it's related to your original employee table. Do you have any questions? Do you have any questions? Because our next topic is relationships. Now we have done designing entity relations or tables. Any questions? Because we want to do a bit of practical session now. Everything is clear? Crystal clear? Because we are not going to discuss this again. So then you go and face your exams, right? We are going to do some past paper discussions, but we are not going to do revision, right? So just remember, we are not going to do it something called revision, right? So you know how the traditionally A level is done. So student go to school in the morning, then student go to tuition classes in the afternoon. So they learn the same thing twice. Now this is first time, this is second time they learn it again. So then when the exams are nearing, they start doing revision classes. So they learn it for the third time also. Okay. So they learn same thing three times and go and face the exam. Sometimes maybe revisions of the revisions. But we do it only once. Of course, you can go to school, that is no issue. But in here we don't do two times. In the class also we don't talk it same two times, same one concept. And we are not going to learn this again after another 6 months, okay? But we are going to do some past paper discussion. Past paper discussion is not revision. Okay. If you need revision, go and download, go through the recordings, okay? Quick recordings, 2 hour recordings. Right. So now we are going to do a bit of a design. Remember, still we are in the logical designing. So therefore, ideally, we are not supposed to use a database management system. The moment you use a database management system, you are not in logical design, rather you are in physical design. Right? But you don't feel this unless we do this in a database management system, right? Because you really feel it when we use a database management system and do it. So therefore, we are going to use Microsoft Access. Later, we will use MySQL, especially when we are doing SQL. Okay. But for the time being, we will use Access. If you have Access, of course, definitely you must have Access if you have the Microsoft Office. I don't mind which version of Access you are having, whichever version it's going to work for our examples. So I just open my Access, Microsoft Access. There is a blank database. So it has created one table or one relation. Okay, one table or one relation. So why employee ID is two times? Yeah, so the reason is, now here, this is your employee table. This is your employee table. This is not employee table. This is employee contact, or you can give any reasonable name. So why you have the same employee ID two times? Because this employee has two contact numbers. This contact number is also this employee. This contact number is also for this employee. That is why here you have only once, because primary key you can't have the duplicate values. So here you can't have again 145. Then it will not give error saying your primary key is duplicate. But here the primary key is this surrogated now ID 1, 2, 3, 4, 5, 6. So now if a particular employee has five contact numbers, there will be five records, and each five records will have the same employee ID. Okay, is it clear? Now, if I don't go for another this kind of an additional table, sometimes you may feel like, okay, this is headache, right? Additional table, relationship. So what is the other option you should have thought of? So other option is don't go for a separate table. Use the same table. Something like this. Employee ID, name, contact number. Say 125, Nimal Silva. So then you write note 71, blah, blah, blah. say 145, Ravi Fernando, maybe 077, blah, 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 comma, 0757, blah, blah, blah. So you may feel like this is easier solution, right? So this is much compact, easy solution. Just one table and comma separated, you have all the contact numbers. If you have five contact numbers, comma separated, those any character, you keep five contact numbers, right? So then you should ask, I feel like this is good, simple, not like creating another table, relationships. So this is a simple solution, right? So as engineers, we love simplicity. We love simplicity. Engineers' task is make life simple. Develop complex systems, but embrace simplicity. So the best solution is the simplest solution that work. But for complex problems, it is not easy to develop simple solutions. So therefore, yes, it will be complex. For example, building a normal bike is easy, right? So normal bike, but building a rocket is not easy. But unfortunately, using a bike, you can't go to the moon. Using a car, compared to car, rocket is more complicated. Compared to plane, rocket is more complicated. But unfortunately, you can't even use a plane to go to moon. So then you have no other option but design and build that complicated rocket. But the modern rocket is the simplest possible rocket that does the work. That does the work. They keep trying to make it simpler and simpler and simpler. Okay. Now, now you know that after very long period, I think about after 7 years, the government, I think last June, no, April, government relaxed import of vehicles. Import of vehicles. Now all of a sudden people can, for the last 5 years, no brand new vehicle. No brand new vehicle. Even very wealthy people, they use their old cars. But now, all of a sudden, brand new vehicles are coming to Sri Lanka. And especially if you're in Colombo area, you will see that these days when I get out of right, street, I can see plenty of electric vehicles, EVs, everywhere BYDs. So why people are crazy to buy electric vehicles? Can someone tell me what is the main advantage of buying a EV over petrol vehicle? If you look at it from engineering mindset, of course, if you look at it from normal buyer's mindset, you will say maybe your cost is less, like you can charge it using your electric, and if you have a solar, then it's almost no cost at all compared to petrol cost. And there are pros and cons, negative things also, right? New technology, there's a risk of batteries, right? Because it's a new technology, we have not experienced much. That is why they are giving about 8 to 10 years of warranty. So every brand new electric vehicle, they give 8 years of warranty, comprehensive warranty to the battery and everything. Because otherwise people don't buy it. They know. But at the same time, you may have seen that electric vehicles have so many electronic gadgetics, right? So many electronic gadgetics. See, why? Because electric vehicle is so simple. So just you have the battery, then electric motor. So then power is transmitted to the wheels. So there's no engine, there is no gearbox, there's no gearbox. So the vehicle is super simple, right? So vehicle is super simple. So therefore these Chinese people are now giving this and that 10 other feature because they don't have much to do with this. And Japanese people, those Toyota people, Nissan people, Suzuki people, they are so busy improving the engine, improving the gearbox. And there's nothing like that in electric vehicles. So no services, oil changes, nothing. So all these issues are coming with your engine. No engine troubles. So you can see people make things simpler. Electric vehicle is simpler than normal vehicle. So while Chinese people going for electric vehicle, Japanese people going for hybrid vehicle. Hybrid vehicle means you have two vehicles in one vehicle, right? You have the electric part as well as petrol. So that means you are buying something like you are buying a two vehicle now. So now you are going worst case, right? So earlier you had one vehicle. Now you are those who buy hybrid vehicle, they are buying two vehicles, petrol vehicle and electric vehicle. So two headaches. So what about if you buy a electric vehicle? No engine, no gearbox. You don't need to get the certificate for your smoke, right? No unnecessary sound. So we make things simple. So my question is, so then what's wrong with this approach? You have employee ID, name, and contact number. Contact number we can have comma separated. That is simple, right? This is more complex solution. We have to introduce another table also. So what's wrong with this approach? Okay. Again, when you process data, then you need to extract this value and separate by commas. So processing times, unnecessary headache. Unnecessary headache. And also we don't know whether we have one contact number, two contact number. And when we allocate memory for these fields, if a particular record has 10 contact numbers, we need to allocate the same storage for each and every record. But most of the time you have one contact number. But worst case, maybe someone has five contact numbers. So therefore you can't allocate something like this in memory allocation for one field 20 bytes and all the other fields 5 bytes. No. For each and every record is going to have, if it is the maximum now, it's a waste of memory. Waste of memory. Okay. Though you feel like this is waste of memory, this is waste of storage, actual waste of storage is going for that comma separation. And also you will learn this, we will learn something called normalization. First normal form, second normal form, third normal form. Actually, if you go for that comma separated contact number, it simply violate the first normal form. So why these normalization rules? Just to get rid of these bad designs. Bad designs. Thinking about the future. So the moment you go for the single table with comma separated, actually your table is not even in first normal form. That you will learn later. What is first normal, second normal, third normal, boycott normal. Right. So therefore, if you have multi-value attribute, your solution is take it to a separate table and create a one-to-many relationship. Okay. So everything has a reason. I told you there are we are doing science subject, and this subject is there are two types of science subjects: formal science, natural science. So chemistry, physics, biology, natural science, computer science, mathematics, formal science. Formal science you can understand 100%. 100%, not 99.99. So every concept here has a 100% valid logical reason, whether it's maths or computer science. Okay. So therefore, learn it in the proper way. Right. Now let's move on to our, because we want to do some hands-on things. Uh, I told you we will use access. Okay, Microsoft Access. So I have created a table. You can do it with me. You can do it parallelly with me also. I will again start from beginning, close it. So I start my Microsoft Access. Usually if you have Office, Word, Excel, you have the access also. Right. Blank database. Right. By default, it create a table for you. Right. But it has not, we have not given it a name. So when you save it first, it will ask you the table name. I will call this employee. Employee. That is my table or relation. Now remember relation has fields. So how do you decide, how do you define your fields? You right click and say, right click on the table and say design view. It has created one field for you and it has made that primary key also. But I will give it a better name. I will call it employee ID. Employee ID. I just capitalize each word just to make it nice. And you can see there's a small key. See, I don't know whether you can see it. There's a small key symbol. So that shows that this is your primary key because we have only one field. By default, it is your primary key. And when I click on, you can see this is enable primary key. Right? And also it says auto number. Auto number means it's a surrogated primary key. Your access is going to generate that number. Right? Like 1, 2, 3, 4, 5. That is also good, right? Otherwise, we need to keep track of what is the last account employee number and so on, right? Right. So then maybe name, but unfortunately in Microsoft Access, name is a keyword. Keyword. It has a special meaning for Access, so therefore you can't just save it as a name. Therefore, I just call it e-name just to make it different from the word name. And you need to decide the data type. So there are some data types. Don't worry too much about exact data types. Uh, I will go for something like short text. Okay, text or short text. There's something for short text, long text. Don't worry, just select something text because name is a text. Right? Maybe I want date of birth. I just call it DOB or something. Or maybe salary. Salary. So there's a data type called currency also, but you don't need to worry about this data type because this is just to understand the designing. Later we will use MySQL. So you need to know the MySQL data types, but not here. Okay, this is just we want something to play with. But I will call this salary as maybe number, or you can even go for currency. But I will go for number, and maybe DOB date of birth. You can go for date time. Okay. Now I have few fields and this is my primary key. If I want to change it to e-name, just click on that, right click and say primary key. Right now it is e-name is the primary key, but I just want to make employee ID primary key. I will just click on that and change the primary key. So then this is removed and this added. Right now I have table with a primary key. Now if you want to add some data, you can save it and double click or you can say open, not design view open. Now you can see the fields. You don't need to add the employee ID because it's auto number. Maybe name, say Nimal, say salary, 100,000. Say date of birth, I will just add a crazy number date, okay, because I'm lazy. Uh, right, so then you can see already it is one. I'll say Nimali, say 120,000. I'll just add some crazy date, okay. Maybe just one more. Rehana, 95,000. Some date, okay. Right. So this is my data. I can save it. Okay. Right. So that is how you work with entities or tables or relations. You can add fields, you can delete a field, you can change the data type, you can change your primary key. Okay. You can make a primary key auto number or surrogated key. Is it clear? So later we will create similar to this in MySQL when we do SQL. Okay. Right. So I'm not going to design something like this yet because we have not discussed about relationship. Remember, we need to create a relationship between these two tables. That is what we are going to discuss now. Okay. Relationships. First of all, you must know exactly what is meant by relationship, right? Because sometimes what happens is some stupid students are so busy creating relationships, creating databases, creating tables, writing SQLs, and if someone asks what is a relationship, they looks very stupid. Actually, they are stupid because they do things that they don't understand. So those who do things that they don't have any idea is called crazy people. Pisso. Pisso. Fine. Crazy people. So therefore, first of all, you must know what is a relationship because we discussed what is a relationship in our previous topic. Right? ER diagram, entity relationship diagrams, right? So what is P by relationship? Anyone? Say employee department. Employee work for department. Say one employee can work for one department at a time. Department can have many employees. Now, what is mean by relationship? Because that is analyze and model. Now, designing a relationship. What is mean by relationship? Anyone? Because the definition of relationship is not going to change from analysis to design. Relationship is a relationship. Entity is anything that we are interested, right? Attribute is a property of an entity. So likewise, what is mean by relationship? So relationship is because no one gives me the answers. They can copy so in no, na? Right? මං පිස්සෝ එක එක වැඩ කරනවා බිසි හැබැයි පිස්සෝ ඇහුවොත් එන්නේ මොකද්ද කරන්න කියලා දන්නේ නැහැ. Right? So relationship is a logical connection between two or more entities or between entities. Say student register for a course. Register for a course. There's a relationship. Okay. It's a logical connection. If there's no connection, don't draw a relationship. Okay. Don't draw. Okay. Right. So how do you create relationships? So how do you design relationships so that later we can develop it? So relationship is a logical connection between entity instances. If you want to be very precise, Nimal work for HR department. Okay. Rehana make an appointment for Dr. HR Vikram Singh. Okay. Kapila registered for A-level ICT course. A-level ICT 2026 course. So a logical connection between entity or entity instances. Because in reality, it is entity instances. Right? Employee work for department, student follows courses, customer pays an order, payment is done for an order, or you have done the payment for that particular order. Right? How to create relationships in relational databases? How to create relationships in relational databases? So that is our next question, right? So we create relationship with the help of the concept of foreign key. So the simple answer is how to create relationships in relational databases using foreign keys. Simple as that. That is the short answer, right? So if someone asks how to represent a record or identify a record uniquely in a table using primary key, how to create relationship in a relational databases, use foreign key. So then if someone asks what is primary key, the field that we can use to uniquely identify a record in that relation or table. So then if someone asks what is foreign key, you must have a very precise answer. So that is called confidence. So when you go for the exams, right, in 2026, somewhere around August, right, that is next year, in about 1 year time, you will be going for your A-level exams, right? So you must go with a lot of confidence, smiling, not afraid of exams, right? Smiling if you know your subject. But some others, when the exams are nearing, they get stressed. Sometimes some students are hospitalized also. They can't tackle that pressure because they had kept memorizing things that they don't understand. Right. So therefore, what is a foreign key? So how to create a relationship? By using a foreign key. By using a foreign key. So if someone asks why do we need foreign keys to create relationships? So what is a foreign key? Foreign key is a field in a table which is mapped to the primary key of the related table, thereby creating a relationship. Simple as that. So this relationship is made by this foreign key. So foreign key is a field in a table which is mapped to the primary key of the related table. So why do you create the foreign key? Because it creates this relationship. There's no other way to create relationships. So this is a relationship between employee and department. Employee works for a department. Department has many employees. Employee work for one department at a time. Okay. So you must be very comfortable or very sure about the difference between primary key and foreign key. So every table has a primary key. So primary key is used to uniquely identify a record. So employee IDs uniquely identify employee record. Department IDs used to uniquely identify department record. So foreign key is used to create a relationship between tables. So what is a foreign key? A field in a table which is mapped to the primary key of the related table. So therefore, always your primary foreign key is mapped to a primary key of another table that create the relationship. So if someone asks what is a foreign key, now you must have the world's best answer. World's best answer, not Sri Lanka's best. World's best. And go and challenge someone. If you have a better answer than this, you can tell. So that should be your character. That should be your character, right? Don't second to anyone in life. Intellectual level. I'm not asking you to challenge physically others, right? So physical strength was significant when we were in the jungle for survival, right? But now the strongest person is the one who having the strongest intellectual capacity, not the strongest physical fitness. because we are no longer animals. We are civilized people. Okay. Right. So now you know what is relationship is, right? And also what is a foreign key is. Relationship is a logical connection between entities. Foreign key is a field in a table which is mapped to the primary key of the related table to create a relationship. And you can see there's a connection between primary key and foreign key. Why? Your foreign key, every foreign key is mapped to a primary key. So every foreign key in a table is a primary key in another table. Okay, so that is why sometimes you get confused, right? Because it's a foreign key next table, but it is if it is a foreign key, definitely it must be a primary key in another table. Okay, but for a primary key in another table, for this table, it is foreign key. Right? How do you create a foreign key for one to many binary relationship? Okay, one to many because we are going to take scenario by scenario. One to many binary, one to one binary, many to many binary, then one to many unary, one to many binary, sorry, one to one unary, many to many unary. Then we are going to even look at ternary. So then we are done with the relationships. Then you know how to design your relationships. Okay, so then with pretty much our design topic is over. Then we move on to a special part of the designing called normalization, which is a very small topic. Okay, so remember, foreign key is a column in a table which is mapped to the primary key of another table. So therefore, make sure that your foreign key has same data type as this primary key. Not necessarily same name. If it is employee number here, you can either call it employee number or anything else. It is not a must. But always best practice is use the same name also. Then very easy for someone to find out, okay, this is the foreign key for this one. But if you want to make others life complicated, confused, just use a different name. That is fine. You have all the rights to do that. But I always use the same name because I want to make my life simple. I want to make my life simple. So that is why we do this class only 2 hours. Because I like to do this in 2 hours and enjoy another 1 hour rather than doing this class for 3 hours. Because I know that we can do it in 2 hours. So likewise, if you confuse others, they need more time. Right? If you mess things, right? If you mess your house before your parents come home, then they need to work extra, right? But if you don't mess it, then they have a lot of extra time. They have free time. So you decide whether your parents have free time or not, right? If you extend your A level to 3 years, so you fail in the first attempt. So that means your parents need to work harder, right? So don't do that. And you also need to work, right? Extra 1 year. So don't mess your life. Plan out and do it in a proper way. Okay. Right. So therefore, make sure your data types are compatible. But name, not necessarily the same, but best practice is use the same name. Best practice and rule are two different things. Okay. But disciplined people follow best practices like rules because best practices are for the best results. Okay. For example, if you walk in the right side, that is a best practice. It is not a rule. So remember, in road there are rules. So vehicles are supposed to drive in the left side. Okay, left side. It's a rule. If you drive in the right side, you will get fines. But when you walk, there's no rule saying you are supposed to walk in the right side. It's just a best practice. So, but when I walk, I always try to walk in the right side because it's a best practice. So then I can see the vehicles coming closer to me. Right? So therefore, not only I drive my vehicle in the left side, I always try to walk in the right side doors whenever possible. This is a rule. This is a best practice. So the rule is use the compatible data type. Best practice is same. Use the same name as much as possible as well. I use both. But in the exams, if they ask, is it a must? You can say, no, it's not a must. Just like saying, no, it is not a must to go walk in the right side. You can even walk in the left side. Okay. Right. So when it comes to relationship, as I told you, now we are going to look at how different relationships are made. So how do you categorize the relationship using the degree and multiplicity, which we have already discussed. So why do we have this? Because then we can identify unary one-to-one, unary one-to-many, binary one-to-one, binary one-to-many. It's good for our term. It's then we have proper categorization. Okay. So these are not to give you headaches. These are to make sure that you think in a proper way. You communicate in a proper way, especially when you work as a team. You develop software as a team. So then your design team use the same terminology. Okay. Right. What is the degree of a relationship? How many entities or how many relations are involved in the relationship? How many entities or relations or tables? So this is one, sorry, this is binary relationship. This is unary relationship. We discussed that. This is ternary relationship. Right? If it is more than three, you call it n-ary and so on, quaternary. Okay. Binary, unary, ternary. We are going to look at how to create unary relationships, binary relationships, ternary relationships. So degrees, how many entities are involved in the relationship. So then multiplicities for the cardinalities, one instance of A, how many instances of B is related? And with one instance of B, how many A instances are related? Remember, I gave you a definition. I am not going to change that definition, right? Week by week. So what is multiplicity? Multiplicity of a relationship is, say we have a relationship between A and B. Now you can see that in analysis, we draw like this. But when it comes to designing, we skip it. We make it even simpler and you draw like this. So multiplicity or cardinality of relationship is with one instance of A, how many B instances are related? Say many. With one instance of B, how many A instances are related? Say one. So then it is one to many. It can be one to many, it can be one to one, it can be many to many. So we are going to look at how to design one-to-one relationship because we have already identified it is a one-to-one, right? In the analysis, like husband and wife, like it's one to many, mother and child. Mother can have many children, child can have only one mother. Or many to many. Student can register for many courses, course can have many students. Now, how to create the tables? If it is one to one, one to many, many to many. Okay, so now we have the terminology. වචන set එක දැන් අපි හදාගන්න තියෙන්නේ. So then we can combine you binary one to one, binary one to many to many. Unary one to one, unary one to many, unary many to many. Ternary, of course, ternary we don't go for one to many to many. Just we look at it as one concept, ternary relationships. Okay. So this again just refreshing what is one-to-many relationship. So one record is mapped to many records in B, but one record in B is always connected to one record in A. There's nothing like this. There's nothing like this. You can't say that one record of B is mapped to many records of A. No. If that situation is there, it is not one to many. This is one to many, right? Not many to many, or one to one. Okay. Sometimes we say C one to many, or sometimes we say one to zero many. But simply we say one to many. One instance of A is related to many instances of B, or possible for many instances of B. But one instance of B is related to only one instance of A. Okay. So instance of B can be related to one instance of A. When I say one, zero, one. When I say many, zero, many. So how do you, okay, what is time now? Right, it's past 6, right? Right, so we'll discuss this, we'll look at how to build, make binary one to many, binary one to one, binary many to many, then unary one to one, unary one to many, unary many to many, ternary relationships. That is the most important part of your database subject. So therefore, make sure you look at up to this point and use access and create a table, because using access we are going to create all these relationships. One-to-one relationship, one-to-many relationship, many-to-many. So you must know how to create a many-to-many. Especially when we create many-to-many, you need to introduce another table also. We call it connecting table. So this is the hardest, not hardest, actually the heart of the designing. SQL is very easy for someone who, if you know you're designing. Okay. Right. We stop at this point.